Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we continue the domain 4, that is cost optimized design the cost optimized architectures, and our focus is on a topic that is one of the most important for real world AWS design, which is cost optimized compute solutions. Compute is usually the most expensive part of AWS infrastructure, especially when your workloads run 24/7 or operate at scale. In this session, we will learn how to choose the right compute services, selecting the right instance families, applying the cost savings models like spot, reserved instances, and savings plans, and also how to use the modern compute patterns like serverless and containers to reduce the cost without sacrificing the performance. Let's get started. Before we optimize the compute cost, we must have proper cost visibility. AWS provides cost allocation tags, which helps you identify exactly which workload, team, or the environment is consuming compute resources. These tags become essential when analyzing the EC2, ECS, EKS, or the Lambda usage. With AWS organizations, multiple accounts can be centrally built, enabling proper chargeback and governance models. Multi-account setups prevent noisy neighbor issues and give each workload its own cost boundary. These foundational tools ensures that whenever we optimize the compute, we can clearly measure where savings are happening. To design cost optimized compute architectures, you need the right monitoring tools. The first one is the Cost Explorer. It gives you instant breakdown of EC2 instance usage, RI and savings plan coverage, and also the Lambda cost distribution along with spot usage. AWS Budgets allows you to set custom billing thresholds so you get alerts before computing costs exceed the expectation. For deep analysis, the cost and usage report provides the most granular report and commonly used for automation, BI dashboards, and enterprise level cost reporting. These tools collectively ensures the continuous cost optimization across all the compute workloads. Compute cost optimization is not just about selecting an instance type, it also includes where the workload is deployed. AWS regions differ in prices for EC2, Lambda, EKS, and other compute services. Placing compute close to your users reduces the latency, but also choosing the cost optimized regions helps reduce overall spend. Multi-AZ placement also influences the cost. More redundancy means more compute usage. So architect must strike a balance between reliability, performance, and cost. AWS provides multiple purchasing models to help reduce compute costs. On demand is the simplest and most flexible, but also the most expensive. Reserve instances gives you about 72% savings when you commit to the using specific instance types for 1 to 3 years. Saving plans offer similar savings with more flexibility. They apply across EC2, Fargate, and Lambda. Spot instances offer up to 90% savings, which is ideal for stateless, fault tolerant, and workloads. Choosing the right purchasing mix is one of the most powerful ways to significantly lower the compute cost. To reduce the compute cost, selecting the correct instance type and family is essential. General purpose instances serve most workloads, but compute intensive jobs work better on the C series, while memory heavy applications benefit from R or the X series. Storage optimized and the accelerated computing families are designed for specialized workloads. One of the most common cost issues is oversized instances. Many workloads run comfortably on smaller instances when properly right sized. Using the AWS Cost Optimizer helps identify right sizing opportunities automatically. AWS encourages architects to shift away from the fixed static compute wherever possible. Compute efficient patterns like containers reduce the overhead by packing workloads efficiently. Serverless ensures you pay only for the actual usage instead of pre-provisioned capacity. Microservices break the large monolithic applications into smaller, independently scalable components, ensuring that only what needs scaling actually scales. Event-driven compute like Lambda and step functions eliminate the idle computing costs completely. Scaling plays a major role in compute cost optimization. Horizontal scaling adds more instances when required, while vertical scaling simply increases an instance size. Automatically scaling ensures workloads scale only when needed and scale down during low traffic, which reduces the waste. EC2 hibernation allows long-running workloads to pause and resume without paying for compute during downtime. Serverless workloads automatically scale to zero, offering the best cost optimization for intermittent tasks. Selecting the right compute service is central to cost optimized design. EC2 is powerful but often over-provisioned. For predictable workloads, RIs and the savings plans reduce the cost significantly. Lambda provides the most effective, efficient cost model for sporadic and event-driven workloads. Containers running on ECS Fargate offer the perfect balance between the flexibility and lower operational overhead. The key is matching the workload behavior with the compute model that delivers the lowest cost without impacting the performance. Some workloads cannot run entirely in the cloud due to the latency or the compliance requirements. Hybrid compute solutions like AWS Outposts and the Snowball Edge bring the AWS compute to on-prem or the edge environments. This reduces the latency and minimizes data transfer costs, especially for the workloads that generate large data volumes but only sync final outputs to the AWS. Hybrid architecture allows cost savings by processing and filtering data before sending it to the cloud. A cost-optimized compute design combines multiple strategies. Choosing the right instance family, applying the correct pricing model, leveraging the containers or the serverless to eliminate the idle capacity, and using the autoscaling to dynamically adjust compute resources. This layered approach ensures that your workload remains reliable, high performing, and cost efficient, which is exactly what AWS expects from a well architected design. So to summarize, in this video we explored how to design the cost optimized compute solutions covering instance selection, cost management tools, purchasing models, right sizing, auto scaling, hybrid compute, and how the serverless and containers reduce the compute waste. These concepts are essential for both the exam and the real world cloud projects. In the next video, we will move to the next topic, which is design cost optimized database solutions, where we will explore the caching, retention policies, engine selection, capacity units, cost effective database types, and much more. If you are enjoying this series, don't forget to like, subscribe, and stay tuned. I'll see you in the next session. Thank you.